Good day to all. Today we are going to see about the single piece induction motor. This is the one of the type of the induction motor. See here in the induction motor there are two types. One is single phase induction motor and another one is three phase induction motor. Now we are going to see about the single phase induction motor. This is the introduction of the single phase induction motor. Before that we will see the diagram. Here there is a outer part is stator and inside there is a stator main winding and starting winding. Then the rotor is also there. Then there is a shaft inside the rotor winding. The construction of a single phase induction motor is very similar to that construction of a three-phase induction motor having a spool-phase rotor, except the stator is found on a single-phase supply. Here, this stator will have a single-phase supply over here. Here we will give the single phase, whereas there in the three-phase induction motor we will give to the stator for three phase, but it is a single phase induction motor. So here we are giving a single phase to this given motor. Then stator is also provided with a starting winding which is used only for the starting purpose. This can be understood from the schematic of a single phase induction motor at the left. See the working principle of the induction motor. When the stator of a single phase induction motor is fed with a single phase supply, it produces the alternating flux in the stator winding. If we are giving the power supply to the stator, then it will produce the alternating flux in the stator winding. Then the alternating current flowing through the stator winding causes induced current in the rotor phase, which is the spool phase rotor according to the Faraday's law of electromagnetic induction. This induced current in the rotor will also produce the alternating flux. See here, this is the side of this single phase induction motor. We will supply over for it. Then the EMF will induce over here. The alternating flux will induce over here. This flux will produce the alternating flux in nearer to stator side also. This is the point denoted here. Even after the alternating fluxes are set up, the motor fails to start. The reason behind that, however, if the rotor is given an initial start by an external force in either direction, the motor accelerates to its finite speed and keeps running with its rated speed. This behavior is single phase induction motor can be explained by a double field revolving theory. See, this is the double field revolving theory. We can see over here. This is the A point and this is the B point. With the degree of theta m. If we are given the force to that, then the theta m will have some deflection over on it. Then it will go for 90 degree, then it will go for 135 degree, then it will go for 180 degree, like that. See, in that double field revolving theory states that any alternating quantity, here we can say that alternating flux, right? In double field revolving theory states that any alternating quantity can be resolved in two components having a magnitude of the maximum magnitude of alternating quantity, and both of the components rotating in opposite direction. The figures will understanding about the revolving theory that we will see here. Here we can understand that field revolving theory. Because of this, alternating quantity can be resolved with the two components with the magnitude. Half of the magnitude. You see over here, this diagram will get reflected in opposite direction. Here also in opposite direction. Here also same as that in the opposite direction. Then see why the single phase induction is not self-starting. Here the stator of the single phase induction motor is wound with a single phase winding. When the stator is fed with a single phase supply, it produces alternating flux which alternates along one phase axis will be. But the alternating flux acting on a spool cage rotor cannot be produce a rotation. Only revolving flux can produce. That's why the single phase induction motor cannot have self-starting mode. See why? Because the alternating flux is produced, but this alternating flux actuating a spool cage rotor cannot rotation only revolving. It cannot rotate the rotor side. It only revolving the rotor side. That's why here we cannot do the self-starting in the single phase induction motor. Then how to make a single phase motor will have a self-starting. As explained above, single phase induction motor is not a self-starting. To make it self-starting, it can be temporarily converted into two-phase motor while starting. This can be achieved by introducing an additional starting winding, which is also called the auxiliary winding. So, hence, the stator of single phase motor has two windings. One is main winding and another one is starting winding, or otherwise we can say as a auxiliary winding. See, these two windings are connected in parallel across the single phase supply and are spaced 90 electrical degrees apart. The phase difference of 90 degrees can be achieved by connecting the capacitor in series with this starting winding. Hence, the motor behaves like a two-phase motor, and the stator producing the revolving magnetic field which causes the rotor to run. Once motor gathers the speed, it's you can say up to 80 to 90% of its normal speed. Then the starting winding gets disconnected. Then the circuit by means of centrifugal switch and the motor runs only on the main winding. See, from the starting stage, the motors behave like a two-phase motor, and the stator producing the revolving magnetic field which causes rotor to run. Because here it's the auxiliary winding is also there. If once the motor gathers the speed for that particular speed to run that motor, then we can say that the motor speed, if it will reach to 80 to 90% of its normal speed, then there is no need of that auxiliary winding. Its main winding, it is more than enough. There is no need of starting winding, or you can say that auxiliary winding. So that time the starting winding gets disconnected from the circuit with the help of centrifugal switches. Once it will reach that particular speed, then the centrifugal switches will cut off that starting winding. Then the motor will run only on the main winding. Now there is a no need of auxiliary winding. These are all about the single phase induction motor.